All right, guys, good morning. Wongsoria, Sumawate, and Kim Sin, Duch, Kim Lux, and others. Guys, I hope you are doing well. As I actually mentioned in the email, okay, I had to do something this morning. Actually, I had somebody to fix the aircons, but they couldn't finish on time, and decided to have online class with you. Okay, but still, as I told you, we have 7 sections, or let's say 6 sections for you. Okay, and still, if you want to join the physical class this afternoon from 1 to 3, or tomorrow, okay, 10 o'clock, or Friday, 11 o'clock, you can join also those classes, any of these classes, okay? Even other times also, even if you have physical class, but you're late or you're busy, you can join any of these classes since they are all the same, and the same course. I'm teaching the same concepts. So now, yes, that's right, Kim Lux. I have class of other groups, but they are not so big, right? You can join them. Not all the students at the same time. Let's say, for example, 5 people, they are free at 1 o'clock, and 5 people at 2 o'clock, or maybe you want to join tomorrow or Friday. Okay, I mean, only for this week, because next week, most probably, we will have only online class. After next week, also it is Khmer New Year. Because of this holiday also, I think we'll have only online class. And after 2 weeks, we will see again. Okay, right now, we don't have to talk about far future. Okay, let's focus on this week. Okay, then again, it is optional, all right? I mean, if you really want to join, you can join. But if you think that and this much is enough, you can study yourself. Also, it is fine. So, guys, as you know, we were talking about optimization problems. Yesterday, we did, I think, 3 questions or 4, I guess. So now we will continue from where we stopped, okay? So I think maybe we are going to consider 3 questions with you, okay? So another application, okay, actually related to optimization is from physics. It's about the speed of the light. And the speed of light depends on the medium through which it travels, and is generally slower in denser media. Media or medium. Media means a plural form, right? Media or medium, like for example, the light is going through the water or air or gas, or I don't know, depending on the medium, and also it is speed changes. Okay, so Fermat's principle in optics, that's also just principle. So actually, usually they actually obtain these principles by performing or doing a lot of experiments, right? So states that light travels from one point to another point along a path for which the time of travel is a minimum. That's also interesting thing. And the light, and just choosing the minimum path to travel from one point to another point. It says that states that light travels from one point to another point, right, along a path for which the time of travel is minimal. And this kind of situation or phenomena, you see this a lot of, I mean, if you observe this, like among animals or insects or other beings, right? Like, for example, let's say lizards, it sees something on the wall from one corner to another corner, it must move. Okay, with a straight line is understandable, but how about if you're actually standing on one wall, but your actually prey is on another side of the wall? So actually they will choose the shortest path and attack. And also animals, a lot of times they do the same thing, okay, for their prey, or to move from one point to another point. Okay, we don't know how they calculate. Maybe somebody teach them, all right, or taught them how to do that. They calculate the best and the shortest path, and also after that they choose this and move through this path. Even the birds, for example, when they migrate from one point to another point, I think this is the air, right? How do they choose the minimum path in the air? They choose the minimum path. According to this, they actually keep their energy and fly from one country to another country, or even from one continent to another continent. In Cambodia, maybe you have never, I have never noticed, for example, but in our country, when spring comes, you will see a lot of birds. When actual fall comes, they will migrate to other hotter countries. The countries means it's a long distance, right? I don't think they have a rest in the middle, because when just start flying, they fly continuously. Anyway, so it's something similar to this. Fermat's principle in this optics states that light travels from one point to another point along a path for which the time of travel is a minimum. Describe the path that a ray of light will follow in going from a point A in a medium where the speed of light is c1 to a point B in the second medium, this is a second medium, where its speed is c2. So now as see here in this diagram, point A, right? The light is traveling from point A to point B. But to some reason, okay, point A is located in one medium and point B is located in another medium. It's like, for example, you are standing near the ocean or the river, or let's say the lake, right? And under the lake, for example, you see the fish, right? And when you look at the fish, of course, here we have some kind of diffraction. We call this diffraction, okay, because they're light. And that's why it doesn't actually see this directly. It actually, the light breaks actually at the point of intersection of these two mediums. Anyway, to do this one, we know that number one from physics, right? Time is equal to distance over speed. Speed means rate, right? Speed means rate of change of distance per unit of time. So now using this one, if I just introduce coordinate axis, okay, we just know point A and point B, and also suppose that we know their distances. Otherwise, we need a bit more information, right? From how far are they away from each other. Now, if you introduce y-axis and x-axis, and this x-axis it passes through the intersection of these two medium, okay? And at the time, they form some angles. Let's say the angle formed by the y-axis and this AP, the intersection point is P, is, let's say, theta 1. And the angle which is formed by this vertical line, again, and this PB, let's say it is theta 2. Okay, and also label that actually the distance between 0 and P, it is X, and from P to B, okay, in actual horizontal distance, that is D. At that time, as you see here, we have now two right-angled triangles. So one is AOP, the second one is P, maybe let me just write here, HHP. We have two right-angled triangles. And now, how do you find the time? We know that actually by using this time equals distance over rate formula, right? And T1, because in the medium one, the speed of the light is C1. And what is the distance traveled by the light from A to P? It's just AP. And by using Pythagoras theorem, AP squared is equal to A squared plus A squared. Okay. So this A squared plus X squared is equal to AP squared. Or from here, AP is equal to square root of A squared plus the X squared. And that's why here we have AP, the distance traveled by the light, is square root of A squared plus X squared, over its speed is C1. And how about for medium 2? Again, from here, the distance traveled by the light is PB, because it's traveling from P to B. And again, using Pythagoras theorem, what is PB? PB is square root of B squared plus D minus X squared, because the distance is D, right? And distance from 0 to origin of the coordinate axis to P is X. So here we have B squared plus D minus X squared over the speed. And speed of the light in the second medium is C2. So now if you just combine this, I can find the total time, right? What is the total time of traveling or elapsed time from traveling from A to B? A to B, that's equal to T1 plus T2. And what is our task? What are we trying to do here is we're trying to find the condition for where the time is minimum. So for the time to be minimum, how the things must be related to each other. Things means that actually the C1 and C2 and the theta 1 and theta 2. Okay, so now if you just find the total time, then T1 plus T2, we are just adding these two times. It gives us the total time that's equal to the square root of A squared plus X squared over C1. That's the first part, right? Plus T2, that is B squared plus D minus X squared over C2. So now actually time becomes a function of X. And also here, notice that actually as time passes, right? What is it? As X actually increases, that means that the distance is further from this P, right? And also time is increasing because as X changes, time is also passing, right? Elapsing. That's why time is increasing function. It's not like this. For example, 5 milliseconds and after 3 seconds. No, increase. It is increasing. First second, second second, third second, fourth second. It is an increasing function over the interval 0D. Just we have to keep this in mind. So this expression, this equation expresses T as a differentiable function of X, because here A, it is fixed because we know the location of A, and also B, it is fixed, and also distance, it is fixed. What is changing here is, it is X, because how you are looking at traveling this B, right? So here X is changing. So now we want to find the absolute minimum value of T on this interval. So with the shortest time, right, to travel from A to B. To do this one, again, since T is a function of X, we have to differentiate this function and find its critical points, right? After finding critical points, and after we had to find its value at 0, at critical points, and D, and compare these values. Which one is the maximum? Which one is the minimum? It gives us minimum or maximum value. And also here we say, as you see here, actually T is a continuous function. And also we are considering this function over a closed interval 0D, right, from 0 to D. And also if you remember that extreme value theorem, right, if our function f of x is a continuous function over the given closed interval, let's say AB, then over this interval, it must have global maximum and it must have global minimum. So since it is increasing function, it has only we can find it has global minimum, right? So anyway, if you differentiate both sides of this equation, that T is equal to this, right? Differentiate T with respect to X. And just a simple algebra, we know how to differentiate this. We will get this expression that's X over C1 times square root of A squared plus X squared minus, because here we have to the power of 1 over 2. That's why when you differentiate this inside also D minus X, we have minus. Anyway, D minus X over C2 times B squared plus D minus X squared. And now I can just simplify this a bit further. How? Because if you look at this, right angle triangle, and the first medium, actually by using trigonometric ratios, what is actually sine of theta 1? Actually, sine of theta 1, sine of theta 1 is equal to opposite side over hypotenuse. That's equal to X over, what is it, AP. And how in the second one, what is sine of theta 2? Sine of theta 2 is equal to opposite side, that is D minus X over the hypotenuse. Hypotenuse is PB. Now see here we have actually these expressions, X over square root of A squared plus X squared, that's equal to AP. And this B squared plus D minus X squared under the square root, it is PB. So now if I just substitute these expressions, it takes actually just simpler form. That's one advantage of using trigonometric ratios. So now if you just substitute there, now our derivative of T function with respect to T, it takes simpler form. Here we have sine of theta 1 over C1 minus sine of theta 2 over D2. So now we are going to find its critical point, right? It is continuous function, and for this to have either maximum or minimum value, and since it is actually increasing function, right, it must have to find the minimum value, we need to find its critical point anyway. So to find the critical point, this must be equal to 0. So now the function T has a negative derivative at x equals 0. Now that means that actually it is increasing, right, at x equals 0. And if you differentiate this, it is negative. So now it is changing from 0 to positive because it's always increasing. So now if you just describe this and if, what is this figure at 0, dt dx is negative. How do I know that? Again, from this equation, for example, dt dx, right? What happens if x is equal to 0? If x is equal to 0, the sine of theta 1, that's equal to 0, and sine of theta 2, that's equal to also, actually, it is minus y is equal to 0 is if x equals 0, right? And d over pb. And d over pb, in front of d over pb, we have minus, that is minus. That's why at 0, the derivative of the function is negative. And since it is negative, how about at d, it is positive, right? And so by the intermediate value theorem, there must be some t between 0 and d where the derivative is equal to 0. Right, and also actually we can find this by the second derivative test. You differentiate this one more time, and also by just considering this one, actually just a little bit thought, it gives us this conclusion. So there's only one such point because dt dx is an increasing function of x. At this point, we then have the sine of theta 1 over c1 equals sine of theta 2 over c2. The equation which satisfies this must give us the critical point or the minimum value of t. So actually, this is of course a kind of rule in physics. This equation is Snell's law or the law of refraction, and is an important principle in the theory of optics. It describes a path the ray of light follows. Okay, that's a condition for the light to travel in the shortest time from point A to point B, if it's traveling from one medium to another medium. Guys, actually, let's just make a conclude here. What are we trying to do here? Number one is we're just showing one application of derivative, okay, and that's related to, that is used in physics problem. Okay, of course, if you know in details everything, it would be great, but at least you're just getting a taste of this. This thing, it is taught for no reason. There's a reason, because also it is applied in somewhere in some different branches of science. Okay, and another example from economics. R of x, the revenue from selling x items. C of x, the cost of producing x items. Then price is equal to R minus C, the profit from producing and selling x items. Now we are just actually making some hypotheses about the production. Okay, now for example, let's say you have a factory and you are producing what? For example, let's say cans of Coca-Cola here, okay, or some kind of fruit juice. Okay, so now actually you are producing and selling this and collecting money. The money that comes to your pocket, we call this revenue, right? Revenue from this production or sale. And now producing this x items, right? Usually actually this x is integer, but also we can consider this as a continuous function. Like for example, if you produce, let's say 1,000 cans, it has certain cost, right? 1,500 also it is cost. Actually, usually cost is not a linear, it doesn't change linearly. For example, let's say if you're actually the number of items you produce increases by 10%, it doesn't mean that also revenue increases by 10%, right? And because the variable sometimes, if you increase then the production level, and also cost also may increase dramatically, or it may not increase much. And that's why you need to make some adjustment between production level and this cost of producing those X items. Anyway, simply from real life, we know that what is the profit? Profit is selling price minus cost price. But now here we are saying that it is a revenue. Okay, revenue and C. And also they are the functions of X, the number of items produced, because if you produce more items, and also it affects the revenue, and also cost, the same thing. So in economics, actually, this is called, they don't actually call this instantaneous rate of change of this thing. They call this marginal. They use marginal cost, marginal revenue, marginal, price. At the production level, yielding maximum profits. Yielding means obtaining or producing, right? Maximum profit. Marginal revenue equals marginal cost. That means that R prime of X is equal to C prime of X. Okay, so to make a maximum profit, actually the rate of change of revenue must be equal to the rate of change of the cost function. So why is this so? Because if you look at this graph, suppose that here we are x-axis and y-axis, this items produced, this x represents the number of items produced, and this y, let's say it is revenue function. Okay, so now items produced, let's say here we have this blue line. Okay, here we have the cost function, and this yellow function, it is revenue function. And there at these 2 points, they are intersecting each other. You see here, after a certain point, the cost increases a lot if you maximize or increase your production level. So actually this theorem is saying that to get the maximum value, okay, the rate of change of revenue and the rate of change of cost, it must be the same, because these tangent lines, they are parallel to each other. What does it mean? It means that the rates are changing. And also this derivative, we know that it gives us the instantaneous rate of change of these two functions, right? And they are parallel to each other, means that they are increasing at the same rate. At the same rate means that if you just increase your, let's say, cost by 2, let's say if you just double the cost, and also revenue will be doubled, right? It means this, they are increasing at the same rate, means this. If you just triple, for example, the cost, let's say the can of Coca-Cola, it was, let's say it was $1,000, but to some reason, actually it just increases to $3,000 because of gasoline prices, right? And also if your revenue, right, is increased 3 times, right, that means that actually you are making maximum profit here. Okay. Otherwise, in other cases, how about your profit is a lot and cost is less, is also not a good thing, because every economy, they want to make a progress, how to say, smoothly. Okay, not like one day a lot, next day is a little bit. They need some kind of consistent progress. Anyway, guys, let's see one example related to this. Now suppose that r of x is equal to 9x, that is a revenue function, is given by this. Okay, and the c of x is equal to x cubed minus 6x squared plus 15x, that's our cost function. Okay, so where x represents millions of MP3 players produced, is there a production level that maximizes profit? If so, what is it? This r of x equals 9x, most probably this 9 is the individual price of one MP3 player, right? X is the number of MP3 players. If you buy one, you get $9. If you sell 10 MP3 players, you get, what is it, $90. Anyway, so now by the previous thing, right? So now what is the profit then? The profit function is revenue function minus the cost function, right? That is selling price minus cost price. Now from here, what is revenue function? It is 9x minus our cost function, that is x cubed minus 6x squared plus 15x. And which is equal to, I can simplify this further, which is equal to minus x cubed plus 6x squared, and then 9x minus 15x, that's equal to minus 6x. That's the first step. So now it says that to have the maximum profit, right? Actually, this marginal revenue and cost, they must be equal to each other. So now first, when they're equal to each other, we have to find that point, that production level. So what is P prime of x? That is R prime of x minus C prime of x, which is equal to, if you differentiate the right-hand side, that is minus 3x squared plus 12x minus 6. This should be equal to 0, right? Now to find the critical points, first divide both sides by -3. So actually this equation will be equivalent to this equation. X squared minus 4x plus divide by 3, it is 2. That's equal to 0. Now from here, completing the square method, how do you write this? I can just write this equation as x minus 2 squared and is equal to 2. Because if you expand this on the left-hand side, x squared minus 4x plus 4, and take it to the left-hand side, it is 2, right? So what is x here then? If you just solve this for x, so this x will be, x is equal to 2, right? Negative 2, take to the right-hand side, plus minus square root of 2. So it has 2 critical points. Number 1 is x1, that is 2 minus square root of 2, which is approximately equal to 2 minus square root of 2, approximately equal to 0.58. Let me just, actually they are in millions, right? Is it millions? Millions. Let me just write them in thousands, okay? That is 585.786 K. K means, let's say this thousands. And how about the second critical point? It is 2 plus square root of 2. That's approximately equal to, and it will be, I think, 2 plus square root of 2. That's equal to, multiplied by, again, 1000, 3144.213. 213 thousands of, what is it, MP3 players. So is there a production level that maximizes profit? The question is yes. And what is the production level? When you produce 585,786 MP3 players, or 3,414,213 MP3 players, at the time your profit will be maximum. Otherwise, if production level changes between them or outside this actually intervals, either it will be less or even you may make a loss here. That is one example from economics. Well, let's see one more question, and this question we did yesterday in the class. Okay, the last question, I think. Then after that, let's see if you have time. I will continue. Otherwise, I will finish. I don't want to keep you a lot. Maybe in the class we can solve. I'll try to solve more questions. And the 3-meter wall stands 8 meters from the building, and find the length of the shortest straight beam that will reach to the side of the building from the ground outside the wall. Anyway, first, of course, when we are reading this kind of work problems, in the first attempt, you have to read this so quickly and just scan it, right? The second time when you're reading, so read a bit slowly and highlight the keywords and try to understand those keywords. And after that, introduce the suitable variable and solve it. So now we are given a 3-meter wall, right? Stands 8 meters from the building. You'll see here, this 8 meters away from the building. This is our building. And find the length of the shortest straight beam that will reach to the side of the building from the ground outside the wall. Okay, so in many different ways, actually, we can use the straight beam, right? Maybe if we actually just push this towards the building, at the time, we will need a bit longer beam. Otherwise, it will not touch the building, right? And that's why our question is, again, we are going to optimize this problem. That means that what must be the shortest beam so that I can reach the building? Maybe whatever we are doing here. Okay, so we need this kind of beam to make a connection between the ground on the left-hand side of the wall with the building. Anyway, so to do this one now, first we have to model this. So suppose that the distance between the foot of the beam and the foot of the what is it? It's a wall, right? It's a wall. Let's say it is X, okay? And since it's a wall is vertical to the ground, right? Now it is a small triangle, it forms a right angle triangle. And using Pythagoras theorem, again, we can find the length of its hypotenuse. What is the length of this hypotenuse? It will be x squared plus 9. That is the length of the hypotenuse. And also suppose that the length of the shortest straight beam, okay, and the short length of the beam, let's say it is L. So if the length of the beam is L, then this remaining part, it will be L minus square root of x squared plus 9, right? So now I need to make a connection. How can I actually relate this x and the L to each other so that L becomes a function of x? To do this one, we will make use of trigonometric ratio. Let's see here, suppose that the angle between the beam and the ground, let's say it is alpha, right? And for this cosine alpha in a small triangle, cosine of alpha is equal to adjacent side over hypotenuse, right? Adjacent side is x over hypotenuse is x squared plus 9. And how about in a big right angle triangle, the whole beam and the ground, right? And actually adjacent side is x plus 8 over, and how about the hypotenuse? Hypotenuse is equal to L. So now from these two ratios, right, we can relate L and x to each other. Now, if you just cross multiply first, so this L will be equal to x plus 8 times, and here we have square root of x squared plus 9, right? And also now we have x, we have to divide x. Let me just keep this x for now here, okay? So if you expand this, what we have here, x times x squared plus 9 and plus 8 times x squared plus 9. Okay, that's our L. So now from here I can find L. What is L then? It becomes a function of x. Divide both sides by x. So here we have x squared plus 9 plus 8 times square root of x squared plus 9 over x, right? So that is our L function. Okay, so now we have to minimize because the question is saying that find the length of the shortest straight beam. So for this to be the shortest, right, what must be? So we need to find the L. If I know L, I mean the X, right? And we can actually find the length of L. Now, before I continue, just one thing, let me just write here. I'm going to use this repeatedly. What is the derivative of x squared plus 9? Square root of this, that's equal to 1 over 2 times, right? And differentiate inside this, it is 2x times x squared plus 9 to the power of minus 1 over 2, which is equal to x over square root of x squared plus 9. So that is the derivative of this function. Okay, root function. Because see here in the question we have this one. Actually, every time I'm going to use this. So now if you differentiate both sides with respect to x, the first one actually is equal to this. So that's equal to x over square root of x squared plus 9 plus the second one, 8 is a constant number. And open the bracket here. And I should, what is this? Differentiate this. So x over 9. Okay, differentiate this. So first, if you differentiate square root of x squared plus 9, right, that's equal to x over square root of x squared plus 9, right? And times, and here we have x, right? Minus, now here we have x squared plus 9, right? And the derivative of x, that's equal to 1 over. So now we need to what is this? Square the denominator. So here we have x squared. That's equal to this. So now if you simplify this, this will be equal to, just right here. Here we have, what is the common denominator? Common denominator is x squared and the square root of x squared plus 9. Okay. And the first one, what is missing here? X squared. So I should multiply this by x squared. So here we have x cubed, right? Plus, and here we have, it just comes to the denominator, x squared. So here we have 8x squared. And how about this one? Minus x squared minus 9, right? If I'm not wrong, we have 8. Okay. 1x go over this and multiply this. I think we have x here. We have 8 here, and this 8 times 9 is for this 72. Okay. So it gets simpler form because this 8x squared, they cancel each other, and 8 times this 9 is equal to 72, right? Now from here, when it is equal to 0, for this to be equal to 0, this x cubed must be equal to 72, right? Or since you know this thing, I don't need this anymore. Okay. Now let's continue from here. X cubed is equal to 72. So this x must be equal to cube root of, what is it, 72. Or actually that's equal to, what is it, 8, right? It is 2 cube of 9. Okay. So that means that now you can check the second derivative. It will give us the minimum value. So what is the question here? We have to find L, right? So what is the value of L if x is equal to this? At the time we can find L. How? Using this relationship, right? This x over x squared plus 9. Okay, so let me just write here, L minimum is equal to x plus 8 times square root of x squared plus 9 over x. Okay, that's it. So now 1x equals square root of what is it, cube root of 72. If you evaluate this, we just write first cube root of 72. Okay, so now here we have x plus 8. So here we have answer plus 8, close the bracket, times square root of answer squared plus 9, and divided by cube root of 72. So actually, approximately, if you evaluate this, that's equal to 15 meters. So that is the shortest, or is it, beam that can reach to the other side of the building. Guys, we have one more question. We have 8 minutes, okay? I'll just give you some idea, and after that, I will finish the class. All right, solution. In the question, it says that a window is in the form of a rectangle surmounted by a semicircle. The rectangle is of clear glass. You see here, the rectangular part, it's a clear glass. Whereas the semicircle is of tinted glass. Tinted glass is a little bit, maybe it is painted, okay, so that it does not transmit much light. Usually, actually, we use this kind of thing in our cars, right? So that it does not transmit much light. It's a little bit darker, so it just keep inside the car a bit cool. Anyway, of tinted glass that transmits only half as much light. It says only half as much light per unit area as clear glass does. Okay, so that means that, what does it mean? It means that if you're measuring light is something, whatever it is, for example, let's say units, okay, if you just take 1 unit area of this one and also 1 unit area, okay, and from here, if actually, let's say from this rectangular part, if let's say 1 unit area of the light is passing through this, right, and here it is 2 units of light is passing, no, sorry, it's just opposite, right? If this one is 2 units of light is passing through this window, and here we have only 1 unit of light is passing through this window, it means this, right? So the total perimeter is fixed, and find the proportions of the window that will admit the most light. Neglect the thickness of the frame. Okay, so now suppose that actually, since horizontal line, the length of the rectangle is, let's say it is x, and it is with y. And actually says it is x, what will be the radius of this circle? It will be x over 2, x over 2, and x over 2. And the question is saying that the perimeter is fixed, right? The perimeter is fixed. What does it mean? What is the perimeter of the window? That is, here we have y, y. So here we have, starting from this bottom line, x plus 2 sides, it is 2y. And also the top part, right? The top part is half of the semicircle. That is 1 over 2 times 2 times pi times r. And what is the radius of this semicircle? It is x over 2, which is equal to, now this 2, they cancel each other. Here we have pi over 2. So here we have 1 plus pi over 2 times x plus 2y. And actually it is fixed, so this p sub 0, it is fixed, it's not changing, okay? This perimeter is fixed. Now, what is the question? It says to find the proportions of the window that will admit the most light. That means that actually you need to find this proportion, this x to y. So you have to find this ratio, because the rectangle means it has only 2 dimensions, that's length and width. So it's asking about the proportional ratios of their dimensions. What must be the ratio so that it actually admit the most light? Because it says that the most light here, the most light, that's the keyword. Neglect the thickness of the frame. Okay, so that is the first introduction part. The next thing is, now we have to find how much light is passing through the whole window. Now, actually here, L, right? And this from rectangular part, its area is x times y. It times 1 unit area of light is passing through this one, and plus, and how about this semicircle? The area of the semicircle is 1/2 times pi times r squared. That is x over 2, it is r squared. And actually this one, right, is passing, this rectangle is transmitting twice as much as this tilted glass, right? Tinted glass, all right? Tinted glass. That's why here we need to put right here 2, because the light passes through the window, right? It is more twice as much as the light passes through this tinted window. Okay, so now from here, first, if you just simplify this, that's equal to 2xy plus x over 2 squared is 4. So here we have pi over 8 times x squared, right? So now actually this L is a function of x and y. So how can I actually find, the relation between x and y, and using this parameter, because parameter is fixed, right? On the right hand side, we have this. So I can find either 2y in terms of x, or x in terms of y. But since we have x squared, we better find y in terms of x. So from this parameter, right, 2y is equal to parameter minus 1 plus pi over 2 times x, right? Since I have 2y here, that's why I don't have to find y here. So now from here, I can just write our L. Then this L becomes just a function of x, which is equal to, here we have x. What is 2y? 2y is p sub 0 minus 1 plus pi over 2 times x. Put here a rectangular bracket here. Okay, and plus also here we have pi over 8x squared. Okay, so now for this to transmit maximum amount of light, we have to differentiate this, find this critical point, and after that find y and find the ratio. Okay, that's all for this class. Okay, for optimization problems, and the next week we'll talk about the last topics. And have a good day. Enjoy your lunch. See you next time. Thank you. Bye-bye.